Picture this. You wake up tomorrow morning. You check your phone. And the first notification you see is not from a friend. It is from a scientific alert system buried under a kilometer of rock in Japan. The message is 3 words. Neutrino burst detected. You do not fully understand what that means, but every astronomer on Earth does, because that message means one thing and one thing only. Betelgeuse just died, and the light from the explosion is still 24 hours away. You have one day before a second sun rises in the east, one day before the sky changes forever, one day before the constellation you grew up with loses a star permanently. This is not science fiction. This is the exact sequence of events that will happen. The neutrino detectors are running right now. The alert system is armed, and the star that will trigger it is not stable anymore. It has a hidden companion we did not know existed 3 years ago, and that companion is tearing it apart on a 6-year cycle. The textbook said Betelgeuse had 100,000 years left. The textbook was wrong. Stay with me, because by the end of this video, you will know exactly what the warning looks like, exactly what happens to the sky, and exactly why the timeline that every astronomer trusted has quietly collapsed. For most of recorded history, Betelgeuse was background scenery, a fixed red point in the shoulder of Orion, reliable, predictable, permanent. The official line, the one from every textbook, every astronomy class, every documentary, was simple. Betelgeuse will go supernova eventually, but eventually means 100,000 years from now. No urgency, no rush. Sleep well. That story has quietly collapsed in the last 18 months, and almost nobody outside professional astronomy has noticed. Here is what we actually know. Betelgeuse is a red supergiant 700 times the diameter of our Sun. If you placed it where our Sun sits, its surface would extend past the orbit of Jupiter. Every planet in our inner solar system, Mercury, Venus, Earth, Mars, would be inside it. It is running out of fuel. Its core has been converting lighter elements into heavier ones for millions of years, and it is almost at the end of that process. When it runs out completely, the core collapses in less than 1 second, and then the outer layers explode outward at 10% of the speed of light. That is the supernova. The question has always been when, and the answer we were given, 100,000 years, was based on a model that treated Betelgeuse as a single, isolated, stable star. It is not. And the moment scientists realized that, the entire timeline broke. Go back to late 2019. Between October 2019 and February 2020, Betelgeuse did something it had never done in the history of modern observation. It dimmed. Not by a little. It lost roughly 60% of its visible light output. To anyone looking at Orion that winter, the constellation looked wrong. The hunter's shoulder had gone faint. Astronomers called it the Great Dimming. The first explanation was dust. The star had coughed up material from its outer layers, the material condensed into a cloud of carbon and silicate particles, and that cloud was blocking our view. The star was fine. The dust was just in the way. By April 2020, the dust cleared and brightness returned to normal. Mystery solved. Except it was not. When astronomers went back through the high-resolution spectroscopic data, the detailed measurements of the star's light across every wavelength, they found something the dust hypothesis could not explain. The surface temperature of Betelgeuse itself had dropped, not by a statistical wobble, by 100 to 200 degrees Kelvin across the entire photosphere. Dust does not cool a star. Dust just stands in front of it. If the temperature dropped, something structural was happening inside Betelgeuse that the textbook treatment never accounted for. The current best model is a hybrid, a large convective downflow, Imagine a massive column of cooling gas sinking through the star's surface, lowered the surface temperature in Betelgeuse's southern hemisphere. That cooler region then allowed local dust to condense from material the star was already pushing outward in its normal stellar wind. So the dust cloud was real, but it was not the cause. It was the consequence. And what triggered the downflow in the first place is the part that changes everything. While the dust cloud debate was running, astronomers doing something different started finding the same anomaly. A small, hot stellar object hidden in Betelgeuse's glare, roughly 1 to 1.5 times the mass of our Sun. Hot enough to leave a signature in ultraviolet spectroscopy, massive enough to leave a fingerprint in radial velocity data, and orbiting Betelgeuse on a period of approximately 5.78 years, which lined up almost perfectly with a long secondary period that had been showing up in Betelgeuse's brightness record for decades, a cycle that nobody had ever been able to explain. They called it Siwara. And here is the detail that should make your skin go cold. Siwara's orbit is so tight that at its closest approach, it does not simply pass beside Betelgeuse. It plunges directly through the star's outer atmosphere, not through the core, not through the photosphere, through the chromosphere and the inner regions of the stellar wind, like a wrecking ball swinging through fog. Every 5.78 years, this companion star drives directly into Betelgeuse, stirring the plasma, ripping convective cells loose, dragging material out behind it like a wake. And the great dimming of 2019? It happened immediately after Siwara's most recent close approach. The companion plunged through. It tore a piece of the southern hemisphere convective structure free. That structure expanded, cooled, and condensed into the dust cloud that blocked our view. The temperature drop, the dust formation, the asymmetric southern hemisphere brightness anomaly, all of it clicked into place at once. This was not a routine stellar event. This was not a passive dying star running its textbook clock. Betelgeuse is being actively destabilized by a star we did not know existed 3 years ago. And every 5.78 years, that star comes back. The next closest approach is happening now. If the pattern holds, another dimming event is coming. And if the dimming is worse than the last one, the question stops being how long Betelgeuse has left. The question becomes whether it has already happened. Here is the cruel part that nobody warns you about. Betelgeuse is approximately 640 light-years away from Earth, which means every single photon hitting our telescopes today left that star 640 years ago. The light we are seeing right now departed Betelgeuse in the year 1386. The great dimming we observed in 2019 actually happened in the late 1370s. Everything we know about Betelgeuse, every measurement, every spectrum, every brightness reading, is a 640-year-old recording playing on cosmic delay. The star could have collapsed last year, last decade, last century, and we would not know. The neutron star at the center of the supernova remnant might already exist, sitting there in the constellation Orion right now, spinning at hundreds of revolutions per second, blasting jets of radiation into space. We just have not gotten the news yet. The light is still in transit, and we have absolutely no way to look ahead, except one small, strange, extraordinary exception. When a massive star's core finally collapses, the first thing to escape is not the shockwave. It is not visible light. It is a flood of neutrinos, tiny ghostly particles with almost no mass and almost no interaction with normal matter. They pour out of the collapsing core in numbers the human mind cannot hold, and they travel through the outer layers of the star as if those layers are not even there. They slip out ahead of the shockwave, ahead of the photons, which means they reach Earth before the visible light does, between 2 hours and 48 hours before you see anything in the sky. Those neutrinos hit our detectors, massive tanks of purified water buried under kilometers of rock and ice. Super Kamiokande in Japan, ice cube at the South Pole, SNO plus in a nickel mine in Canada. These instruments exist for one reason: to detect exactly this event. Normally, they register a handful of neutrino interactions per day. Background noise. When Betelgeuse explodes, those same detectors will register tens of thousands of events in roughly 10 seconds. An unmistakable signal across every detector simultaneously. And there is already a system in place called the Supernova Early Warning System, SNOOZE, that is designed to do exactly one thing. The moment two or more independent detectors register a coincident burst consistent with a galactic core collapse, SNOOZE automatically issues a global alert. Automated, cannot be suppressed. The data is held jointly by academic institutions across multiple countries. The moment Betelgeuse goes, the world knows within minutes. And then the window opens, somewhere between 2 hours and 2 days. A window of anticipation unlike anything in human history, knowing the supernova happened, waiting for the light to arrive. Imagine waking up to that notification. Schools cancel, observatories open. Every news channel runs continuous coverage. And then, at some moment, nobody can predict to the minute, Betelgeuse starts to brighten. Within hours, it rivals Venus. Within 12 hours, it surpasses the full moon in brightness, but condensed into a single point of light, not spread across half the sky like the moon. A single pinprick, blazing. By midnight on that first night, you will step outside and see two shadows on the pavement. One from the street light, one from Betelgeuse. The Betelgeuse shadow will have a faint red tint, and it will not stop at night. At noon the following day, a second sun will hang in the eastern sky, smaller than our sun, fainter, but visible in broad daylight with the naked eye. Two suns, for approximately 3 months, after which the light will slowly, irreversibly fade, and the constellation of Orion will be permanently altered. The hunter's shoulder will be empty. Every child born after that night will grow up looking at a different sky than the one we grew up under. The neutrino detectors are running right now. Tonight, as you watch this. Super Kamiokande in Japan, ice cube at the South Pole, SNO plus in Canada. All of them watching, all of them waiting. The star in the shoulder of Orion is not what it was. It has a hidden companion ripping its envelope open every 6 years. Its timeline has collapsed, and its death may have already happened. The light is just still in transit. So the next time you step outside on a clear night and find Orion, look at the left shoulder, the red point. That is not background scenery anymore. That is a wounded star. And on some night, in some year, near or far, it will become the brightest thing in the sky. When the neutrino alert goes out, you will find out here first. Subscribe if you have not already, and tell me in the comments, if you had 24 hours between the alert and the arrival of the light, what would you do?